Hello students, in this video I am going to explain 20 multiple choice questions from the chapter Solution of Second PUC. So this will help you to solve the questions arising in competitive exams. First question, the molarity of solution having 18 gram of glucose, molecular weight is equal to 180, dissolved in 500 gram of water is option A 0.2 molar, option B 0.1 molar, option C 2.2 molar and option D 0.5 molar. Let me show the solution for this. So we know that molarity is equal to number of moles divided by volume of solution in liter. So for that first we have to calculate number of moles of solute, that is glucose here. So it can be calculated by the formula mass divided by molecular mass. So mass is 18 divided by molecular mass is 180 equal to 0.1 is the moles of glucose. So next, molarity is equal to number of moles divided by volume of solution in liter. So here, volume of solution is given in gram. So to convert into liter, we have to multiply by 1000. So solve, you will get an answer of 0.2 molar. Hence the correct option is option A, 0.2 molar. Question number 2. The molarity of pure water is option A 18.36 molar, option B 1.16 molar, option C 55.56 molar, option D 5.56 molar. Solution. So density of water, let me take 1 gram per cm cube and its molecular weight is equal to 18. So we know that molecular weight is equal to 18. So therefore 1000 cm cube of water will weigh 1000 gram of water. So we know that molarity is equal to mass of water divided by molecular weight. So mass of water is 1000 divided by volume, here it is 8. So solve, you will get 55.56. Hence correct option is option C, 55.56 molar. Question number 3. The boiling point of a compound is raised by A. Intermolecular hydrogen bonding, option B. Volatility of compound, option C. Intramolecular hydrogen bonding and option D. Non-polarity in molecules. So usually intermolecular hydrogen bonding increases the boiling point of a compound as more energy is required to break the hydrogen bonding between the molecules. Hence the correct option is option A, intermolecular hydrogen bonding. Question number 4. Vapor pressure of benzene at 30 degrees Celsius is 121.8 mm. When 15 gram of a non-volatile solute is dissolved in 250 gram of benzene, its vapor pressure is decreased to 120.22 mm. The molecular weight of the solute is dash. Option A 35.67 gram, option B 355.5 gram, option C 432.8 gram, option D 502.7 gram. Solution. Relative lowering of vapor pressure formula is P0 minus P divided by P0 is equal to W divided by M divided by W divided by M plus W divided by M. So where P naught represent vapor pressure of pure component, P represent vapor pressure in solution, small letter W represent mass of solute, small letter m represent molecular weight of the solute, capital W represent mass of the solvent, capital M represent molecular weight of the solvent. So here P naught is nothing but vapor pressure of pure benzene, that is 121.8, and P is equal to vapor pressure in solution, that is 120.22, and small letter W, that is mass of the solute, is equal to 15 gram here, and small letter m we have to calculate, that is the molecular weight of the solute, and here substitute. Then capital W is nothing but weight of the solvent or mass of the solvent, it is equal to 250, and molecular weight of the solvent is capital M, so that is of benzene, molecular weight of benzene here. So you have to calculate molecular weight by using the formula, so that is C6H12. So 6 C carbon is 6 in number, so 12 into 6 plus 12, so it gives 78. Then simplify this equation, you will get value for M, that is 355.5 gram. Hence correct option is option B. Question number 5. Which of the following is not affected by the temperature? Option A, molarity. Option B, molality. Option C, normality. And option D, formality. So usually molality is not affected by temperature because volume does not involve in molality, which changes with the temperature. So molality formula is moles of solute divided by weight of solvent. So here volume term is not there, so hence it is independent of temperature, because if volume is there means volume changes with the temperature. Since there is no volume term in the formula of molality, so it does not change with the temperature. Hence the correct option is option B, molality. Question number 6. Which of the following salt has the same value of Van 't Hoff factor as that of K3FeCN6? Option A, Na2SO4. Option B, AlNO3 thrice. Option C, Al2SO4 thrice. Option D, Fe3O4. So solution. So K3FeCN6 on ionization gives 4 species, 3 K plus ion and 1 FeCN6 3 minus ion. So here among these salts, AlNO3 thrice also produces 4 species as that of K3FeCN6. So that is Al plus and 3NO3 minus ions. So thus both will have same value of Van 't Hoff factor. Hence the correct option is option B, AlNO3 thrice. Question number 7. The boiling point of water, that is 100 degrees Celsius, becomes 100.52 degrees Celsius if 3 gram of a non-volatile solute is dissolved in 200 ml of water. The molecular weight of the solute is dash. So Kb value is given for water, that is 0.6 Kelvin per mole. So options are A 17.3 gram per mole, B 15.4 gram per mole, C 12.2 gram per mole, D 20.4 gram per mole. So we know the formula for elevation in boiling point, that is delta TB is equal to Kb into molality. So here delta TB represents change in the boiling point after formation of solution, and Kb elevation constant, elevation boiling constant, and molality number of moles of the solute divided by weight of the solvent in kg. Putting the values we get, so delta TB can be calculated by subtracting boiling point of solution from boiling point of pure component, that is boiling point of water. So that is 100 minus 52 minus 100 equal to Kb value is given, that is 0.6 into molality, number of moles can be given by mass divided by molar mass. So mass is 3 gram, molar mass we don't know, let it be capital M only, divided by weight of the solvent in kg. So here it is given in a milliliter, so it becomes 200 divided by 1000. So on solving this for M, so we will get value for M as 17.3 gram per mole. So that is option A. Question number 8. Which of the following is a colligative property? Option A, surface tension. Option B, viscosity. Option C, refractive index. Option D, osmotic pressure. So colligative properties are those properties which depend only on the number of particles. So those may be ions, atoms or molecules present in the solution. For example, elevation in boiling point, depression in freezing point, and osmotic pressure, etc. So here in these options, the osmotic pressure is a colligative property which depends only on the number of particles and not depending on the nature. So hence option D is the correct option. Question number 9. The vapor pressure of benzene at certain temperature is 640 mm of Hg. When a non-volatile and non-electrolyte solid weighing 2.175 gram is added to 39.08 gram of benzene, the vapor pressure of solution becomes 600 mm of Hg. What is the molecular weight of solid substance? Option A 69.45, option B 49.59, option C 59.60, option D 108.30. So solution, so we know that relative lowering of vapor pressure is given by P0 minus Ps divided by P0 is equal to Xb. So which is also is equal to W by M divided by W by M plus W by M. So here P0 is equal to vapor pressure of pure solvent, that is vapor pressure of benzene, and Ps is equal to vapor pressure of the solution, so which was formed after mixing 2.175 gram of solute with 39.08 gram of benzene, and Xb represent mole fraction of benzene, and W, small letter w here represent mass of the solute, that is mass of the non-electrolyte solute, that is 2.175 gram. Small letter m represent molar mass of the solute, that we have to calculate molar weight. So let it be capital MB. Next, small letter w here in the formula represent weight of the solute, same, that is 2.175, and This m represent molecular weight of the solute, and here capital W represent weight of the solvent, that is of benzene, that is 39.08, and capital M represent molar weight, molecular weight of the benzene, that is 78. Substitute the values. So you will get equation like this. So P naught minus Ps divided by P naught is equal to becomes 1 by 16. So that is here P naught is equal to 640 minus Ps is equal to 600. So it becomes 40. 40 divided by 600 is equal to 1 by 16. So solve this equation for MB. So you will get value for MB after solving. So that is 69.45. Hence option is option A, 69.45 is the molecular weight of the solid substance. Question number 10. Which of the following 0.1 molar solution will show maximum boiling point? Option A, sodium chloride. Option B, copper chloride. Option C, magnesium sulfate. Option D, chromium sulfate. First you list out the formulas of all the salts. Sodium chloride, NaCl. Copper chloride, Cu2Cl2. Magnesium sulfate, MgSO4. Chromium sulfate, Cr2SO4 thrice. So of all these salts, maximum number of particles or ions will be obtained when chromium sulfate is dissolved in water. Because when sodium chloride is dissolved in water, you will get one cation and anion, that is Na plus and Cl minus. When copper chloride is added to water, you will get one cation and one anion, that is copper Cu plus and Cl minus. When magnesium sulfate also added to water, we are getting only one cation and anion, that is Mg2 plus and SO4 2 minus. So, but when chromium sulfate is added to water, it will produce two cations, Cr2 plus and 3 anions, SO4 2 minus. Hence, 0.1 molar chromium sulfate will show maximum elevation boiling point, because it is producing more number of particles, which will increase the elevation in boiling point. So hence correct option is option D, chromium sulfate. Question number 11. A certain solution of FeCl3, formula mass is equal to 162, has a density of 1.1 gram per ml and contains 20% of FeCl3. Molar concentration of this solution is dash. Option A 0.028, option B 0.163, option C 1.357, option D 1.47. 20% of FeCl3 solution means 100 gram of solution contains 20 gram of FeCl3. So volume of 100 gram of solution can be calculated by using the formula mass divided by density, because density is equal to mass by volume. So volume is equal to becomes mass divided by density. So here total mass is 100 gram divided by density of the solution is 1.1. So you will get volume of solution, that is 90.91 ml. Then you have to calculate moles of solute, that is moles of 20 gram of FeCl3, that can be calculated by mass by molar mass. So mass is 20 gram mass of solute, and molar mass of the solute, that is FeCl3, is 162. So you will get number of moles of the solute, that is 0.1234. Then molar concentration of the solution can be calculated by using the formula number of moles divided by volume of the solution in liter. So to convert it to liter, so this is milliliter, you have to multiply by 1000. So you will get answer of 1.357 molar. Hence correct option is C. Question number 12. How many liters of ammonia at STP would be needed to prepare 100 ml of 2.5 molar ammonium hydroxide solution? Option A 5.6 liter, option B 0.056 liter, option C 11.2 liter, option D 0.56 liter. So molecular weight of ammonium hydroxide is 35, which can be calculated by adding atomic weights of nitrogen, hydrogen and oxygen present in the molecule. So since molecular weight is 35 gram of ammonium hydroxide is needed to prepare 1 molar solution in 1 liter. 35 gram of ammonium hydroxide in 1 liter solution is equal to 2.5 molar solution. So that is given in the question. So 2.5 into 35 divided by 10 gram of ammonium hydroxide in 100 ml solution is equal to 2.5 molar solution. So then it becomes 8.75 gram of NaOH was dissolved. If you solve this one, you will get 8.75 gram. So when ammonia is added to water, there will be formation of ammonium hydroxide. For 35 gram of ammonium hydroxide, NH3 needed is 22.4 liter at STP. So this is the standard volume value at standard temperature and pressure condition. So for 8.75 gram of NaOH, NH3 needed is 22.4 divided by 35. That is standard value divided by molecular weight into dissolved volume of NH4OH, that is 8.75 liter. So answer is 5.6 liter, option A. Question number 13. Which of the following statements given below regarding properties of solution describes a colligative effect? Option A. Boiling point of pure water decreases by the addition of ethanol. Option B. Vapor pressure of pure water decreases by addition of nitric acid. Option C. Vapor pressure of pure benzene decreases by the addition of naphthalene. Option D. Boiling point of pure benzene increases by the addition of toluene. So we are having boiling point of pure solvent increases by increase in number of soluble particle present in it. So by addition of toluene, boiling point of pure benzene increases. Hence correct option is option D. That is boiling point of pure benzene increases by addition of toluene. Question number 14. The average osmotic pressure of human blood is 7.8 bar at 37 degrees Celsius. What is the concentration of an aqueous NaCl solution that could be used in the blood system? Options are A 0.16 mole per liter, B 0.31 mole per liter, C 0.60 mole per liter and D 0.45 mole per liter. So here we can use the formula of osmotic pressure, that is pi is equal to CRT, where pi is the value of osmotic pressure, C represents concentration of the solution and R is the universal gas constant, T is the temperature value. So rearrange this equation for the C. So C becomes equal to pi divided by RT. Substitute the values. So pi is equal to 7.8, R is 0.082 and temperature is 37 degrees Celsius must be converted into Kelvin scale, that is 37 plus 273 equal to 310. Substitute the values, simplify, and you will get an answer of 0.31 mole per liter. Hence here the correct option is B. Question number 15. A 5% solution by mass of cane sugar in water has freezing point of 271 Kelvin and freezing point of pure water is 273.15 Kelvin. The freezing point of a 5% solution of glucose in water is dash. Option A 271 Kelvin, option B 273.15 Kelvin, option C 269.07 Kelvin, option D 277.23 Kelvin. So we can calculate the Kf value, that is depression in freezing point constant for water, by using the values given for cane sugar solution in water. So that is the delta Tf into W. So capital W is weight of water into small letter w, it is molar weight of cane sugar, divided by 1000 into small letter w. So that represent weight of cane sugar. So substituting the values. So here delta Tf can be calculated by subtracting the freezing point of pure water with the freezing point of the cane sugar solution. So after formation of solution, obviously freezing point of the solution will decrease. So hence pure solvent will have greater freezing point compared to the solution here. So 273 minus, so 273.15 minus 271 Kelvin give rise to delta Tf, that is change in the freezing point. So that you will get 2.15 Kelvin into, so weight of water let us take as 100. So into molar weight of cane sugar, that is 342, divided by 1000 into small letter w, that is weight of cane sugar, out of 100 it is 5 gram. So substitute the values and simplify. For Kf you will get a value of 14.7. So now you can use the value of Kf for calculating delta Tf for glucose solution. So delta Tf formula is Kf into 1000 divided by Wb divided by into Mb. So where Wb is equal to weight of glucose and Mb is equal to molar weight of glucose. Substitute the values. So Kf you calculated in the previous step, that is 14.7 into 1000. Wb, that is weight of glucose, is here also 5% solution, means out of 100 let us take as 5 gram, divided by weight of solvent, that is water, here 100, into molar weight of glucose is 180. So we have to use the formula for calculation of molar weight of glucose, that is C6H12O6. All the atoms atomic weight must be added to get the molar weight. Then freezing point of glucose can be calculated by subtracting delta Tf value from the freezing point of solvent, that is water. So 273.15 minus 4.08. So answer is 269.07. So correct option is therefore option C. Question number 16. 1 mole each of the following compounds is dissolved in 1 liter of solution, which will have the largest delta Tb value. Option A HF, option B HCl, option C HBr, and option D HI. So bond dissociation energy increases in the order of HI lesser than HBr, which is lesser than HCl, and lesser than HF. Hence HF is having more bond dissociation energy. So higher the bond dissociation energy, lower is the degree of dissociation. Hence HF is having lower degree of dissociation. That means HF is most stable halogen acid and HI is the least stable halogen acid. And we also have delta TB formula, that is equal to I into Kb into m. So here delta TB is directly proportional to the molar mass of the acid. So here, so hence delta TB value is largest for HI. All colligative properties depends upon number of particles, because here HI is undergoing more dissociation compared to HF. HF is having higher bond dissociation energy, that means lower degree of dissociation. So number of particles in the solution formed by HF is lesser than that of compared to HI. So HI when added to water, it will produce more number of ions. So if number of ions or number of particle increases, colligative property, that is elevation in the boiling point also increases, delta TB. Hence delta TB is greater for HI compared to all other acids. Therefore correct option is option D here. Question number 17. For dilute solution, Raoult's law states that A. The relative lowering of vapor pressure is proportional to the amount of solute in the solution. B. The relative lowering of vapor pressure is equal to the mole fraction of the solute. C. The lowering of vapor pressure is equal to the mole fraction of the solute. And D. The vapor pressure of the solution is equal to the mole fraction of the solvent. So Raoult's law statement, if you observe, so the relative lowering of vapor pressure is equal to the mole fraction of the solute. Hence here, of all of these, in all of these statements, that is statement B, the relative lowering of vapor pressure is equal to the mole fraction of the solute is the correct one. For that you have to remember the statements given for Raoult's law. Hence correct option is option B here. Question number 18. The value of Henry's constant, that is Kh, is dash. Option A, greater for gases with higher solubility. Option B, greater for gases with lower solubility. Option C, constant for all gases. And option D, not related to the solubility of the gases. So Henry's law is having mathematical expression of P is equal to K into X, where P is equal to pressure of the component. So Kh is the Henry's constant and X is the mole fraction. So higher the value of Kh at a given pressure, lower is the solubility of the gas in the liquid. Hence here option correct one is B, greater for gases with the lower solubility. Question number 19. When 25 gram of sodium sulfate is dissolved in 103 kg of solution, its concentration will be dash. Option A 2.5 ppm, option B 25 ppm, option C 250 ppm and option D 100 ppm. So when a solute is present in very minute amount, the concentration of the solution is expressed in term of part per million, that is ppm. So formula for ppm is any component A is equal to mass of component A divided by total mass of the solution into 10 to the power 6. This is the formula. So substitute the values here. So here mass of component A, that is mass of sodium sulfate, is 25 gram. Convert it to the SI unit, that is kg scale. So it becomes 0.025. Divided by total mass of the solution is here 103 kg into 10 to the power 6. Substitute and simplify this equation. You will get answer of 25 ppm. Therefore, the correct option here is option B. Question number 20. The relationship between osmotic pressure at 273 Kelvin when 10 gram glucose with the pressure P1, 10 gram urea with the pressure P2 and 10 gram sucrose with pressure P3 are dissolved in 250 ml of water is. Option A, P1 greater than P2 which is greater than P3. Option B, P3 greater than P1 which is greater than P2. Option C, P2 greater than P1 which is greater than P3. Option D, P2 greater than P3 which is greater than P1. So we have P is equal to, pressure is equal to weight of the molecule divided by molar weight into volume into R into T. R is the universal gas constant, T is the temperature. Since here weight of the substance all are 10, it is constant. Volume also same, that is 250 ml, and temperature will be same for all the solution. Therefore we can say pressure is directly proportional to 1 by m here. So that is to say pressure is inversely proportional to molar weight of the molecules or solute here. So therefore the solute which is having lower molar weight will be having greater pressure. So glucose, urea and sucrose, if you compare, the lower molecular weight will be for urea. So therefore first comes, so greater pressure is having for urea. First comes P2. So next molar weight is for glucose. So next comes P1. So after that greater molar weight is for sucrose. So it is having lower pressure compared to all other. So next comes P3. So hence correct order is option C, P2 greater than P1 which is greater than P3.